So the whole goal for the next 25 minutes or so is just kind of provide some context, explain what microservices is about, talk about some of the problems that they solve, but also talk about some of the challenges that you might face when implementing an application that uses microservices. Oh, great. Here we go. All right, a little bit about me. So I actually started programming in Lisp way back in the 80s, back when artificial intelligence was hot. I ended up programming in Java, wrote the book Pojos in Action back in 2006, started playing around with this obscure thing called Amazon's Elastic Compute Cloud back in 2007. Because one of the AWS evangelists gave a talk about EC2 back then. And that turned into a startup, Cloud Foundry, which then got acquired by SpringSource shortly before SpringSource was acquired by VMware, where I'd been. And so kind of 18 months ago, left. So I've been working on a startup, doing a bit of consulting. Kind of been sort of getting into microservices. So I have a microservices.io website. And I also kind of a co-organizer of the Oakland, Advanced Scala Reading Group. I think that's what we call it, right, Azad? So if you actually, what? Study group. So we study as opposed to, and get together and meet once or twice a month as opposed to have presentations. So if you've actually been using Scala, then it'd be great if you could join us. And I should say that I'm actually really jet lagged because 36 hours ago, I was actually in Australia and just came back this morning. And that's actually really funny because last Thursday I gave a talk in Australia saying, hey, I'm really jet lagged. And I'm also had a lot to drink because I did it that day because I did a tour of the wine country. So I was in great shape. Anyway, so if I sound incoherent, or more incoherent than normal, that's why. Okay, so really I'm going to talk about two things. One is the monolithic architecture, which is really, the sort of the standard way that I think many of us have been building enterprise Java applications for quite a long time. Look at the issues around that, and then dig into the microservices architecture. All right, so let's imagine that you're building an online store. So I think this is kind of a nice, simple app that just illustrates kind of the way we typically build applications. So almost every app I've built since I started using enterprise Java look like this. So I had a presentation here that, controllers, actions, whatever, that generated HTML. And then there would be various services. So in the case of an online store, you'd have a product service, recommendation service, review service, and order service, and so on. So you'd actually have a nice logically modular architecture. But then what you do is then package the whole thing up in a WAR file, or heaven forbid, an EAR file, and run it on Tomcat. And so, I think, that to me is a pretty standard architecture. And on the one hand, it's pretty good, right? This applications like this are pretty simple to develop. Our tooling is very much oriented around building one thing. They're also simple to test. And they're also easy to deploy. You build the WAR file, you copy it to a server running Tomcat, and you're pretty much good to go. And they're also pretty simple to scale as well. You just run multiple copies of the app behind a load balancer, and you've got something that can scale up to, and also offer higher availability. So for many apps, even modern ones today, this is actually a good way of building applications. The trouble is that, imagine you have a team of people, team of developers. Every day they're adding code. And you do that for a few years, you're likely to end up with this giant, absolutely massive monolith. And the problem with that is that when your application is large and complex, the monolithic architecture has some pretty significant limitations. So you sort of run into problems. And I think I've talked with folks who have like 1 million lines of code that they've written deployed in one massive WAR file. And that's their web application. So among other things, a big monolithic application is very intimidating to developers. It's just hard to find your way around the system. It's hard, it's just, there's too much code for any one developer to fit in their head. It's probably going to have a complex, build mechanism as well. So it's just sort of this thing that's scary and no one understands, and it's difficult for new developers to get started on it. Another problem you run into is that, state of the art today is continuous deployment. So if you have a SaaS application, you can push changes into production many times a day. The trouble is, if all of those changes have to go into this monolithic application, that really doesn't fit with continuous deployment. You end up having these long test cycles because, well, we can't break the application because there's only one of them. And so we end up in this situation where there's fear of change, which means that you do more testing, which means that updates happen less frequently. And, it's just, which ironically increases the probability of failure when you do an update. So, monolithic applications get in the way of continuous deployment as well. This actually is funny. I actually stole this image from Josh. So you can imagine that if you've got a massive monolithic application, that's really going to slow down your IDE. It's just going to use more memory. It's going to make you less productive. And it's also going to significantly impact the startup time of your application, which also can impact you as a developer because you make a change, you restart Tomcat, and then if Tomcat takes 3 minutes or 10 minutes to start up, then you're not going to have many iterations before it's time to go home at the end of the day. So it really does impact developer productivity. And then another problem you run into is that a monolithic application can sort of be a big obstacle to scaling development. You've got a large engineering team, you'd like to break it up into sub-teams that focus on specific functional areas. And ideally, they want to be able to just sort of develop and deploy independently. But if at the end of the day, all of their changes go into one big monolithic application, then you end up having a lot of communication and coordination. So you can imagine the UI team saying, I want to update the UI. There's a keynote upgrade bug on that slide. But then the back-end team says, well, we broke it. You can't update production, right? So, it really just gets in the way of everybody working in parallel. And then, another practical thing is different parts of your application might actually have different sort of scalability or conflicting resource requirements. You could have a very memory-intensive in-memory database or cache in one module, but then you might also have some CPU-intensive calculations, cryptography, image processing, or something like that. And they need to be scaled differently, but if it's all in the same monolith, you can't you can't pick optimal hardware for each individual module of your application. So that's a problem. And then I think lastly, a big problem with the monolith is that it often basically ties you to the technology choices that you make at the start of the project. Because, some new framework comes along, it's hard to actually adopt that within your application without having to rewrite hundreds of thousands of lines of code. So you tend to be stuck with the major technology choices you made at the beginning of the project, which in some cases could be EJB2 and struts1, for example. So now you end up with this massive application no one understands, written in technology that no one wants to use. And that's just sort of ultimately a death spiral. So those are the problems with the monolith. Anyone sort of having those problems? Yeah. Anyone want to say how many lines of code they have in their app? Just a lot?
I know for one method, for one MVC handler, there is 2,000 lines.
Okay. Yeah, on the other hand, I actually admire developers who can write get code that complex to work, actually, because I can't. So that's the monolith. Works really, really well for so relatively simple applications, but then it doesn't scale to deal with complexity. So what do you do about it? So this is a really good book. It's written by some folks who worked at eBay and PayPal, and it's all about scaling engineering in a very sort of generic sense, like building large engineering teams, as well as building scalable architectures. One of the things that they have in this book is the scale cube. So that's a three-dimensional model of scalability. And so along the x-axis, so along the bottom, you have x-axis scaling or horizontal duplication. And that's simply where you run multiple copies of your app behind a load balancer. So that's the standard way that we scale our applications today. And then along the z-axis, they have sort of data partitioning or sharding. And the idea there is that you say use some attribute, use the primary key of a row to determine which one of several servers that row should reside on, or some attribute of an incoming request to route that to the appropriate server. So you can sort of do data partitioning both at the app level, but also at the data level. And interestingly, in both x-axis and z-axis scaling, you're actually running identical copies of the application. But where it gets interesting, which is really what microservices is about, is actually y-axis scaling or functional decomposition. And the idea here is that rather than running identical copies of your code, you actually break up your application by by function. So you end up with many individual smaller apps. And that, and the size of them can vary, but that to me is the essence of microservices. It's y-axis scaling or functional decomposition. So when you apply that to the application, to this online store, you go from something like this, one monolithic WAR file, to a whole bunch of services which can be deployed and scaled independently of one another. And you can even functionally decompose the UI as well. So you actually have several mini web apps. Each one implements one small part of the UI. So the browsing, the checkout, the order management, and so on. And then, so we've applied y-axis scaling, and then you can also apply x and z-axis scaling to each one of those services independently so they can meet their scalability requirements. So that's sort of our modern application architecture. Now in terms of, so we've got this concept of a service and it's a standalone sort of runnable thing. Now what is it? And there's a whole bunch of different options. It could be an actual machine, like an EC2 instance. So that's the way that Netflix deploy their applications. One service instance equals one EC2, or one AMI, which ultimately becomes an EC2 instance. But then a really popular way of deploying applications is to use Docker, which is a super lightweight OS-level virtualization mechanism. So you have one EC2 instance, and then that's actually divided up into lots of little Docker containers. And that's an incredibly agile, incredibly lightweight way of deploying apps, which I'm sure, like a year ago, was like this obscure thing, and now it's Docker this, Docker that, and so on. But there's also some other ways of deploying apps. You could actually have a JVM, a service instance could be a JVM, or you could even pack multiple services into a single JVM. I think I heard of some Chinese internet company that was deploying services as OSGI bundles, right? But they were operating at some huge scale, and so it's kind of like there's a spectrum here between, on the one hand, at the top, you have lots of isolation and lots of manageability of individual services, but the density of them, there's a lot of overhead, right, is actually quite, the density is very low. And as you move to the bottom, you get increasing density and increasing increasingly efficient utilization of resources. So you can just decide where you want to be on the spectrum. With Netflix, where they've got lots and lots of money, they can have one EC2 instance, whereas probably the rest of us would want to deploy as using Docker. Plus, it's much more agile as well. Seconds to build an image as opposed to minutes to build an AMI. And then in terms of, well, how do I break up my application into services? There's a bunch of different partitioning strategies. You could partition by noun. So, in this example, things to do with product information, there's a noun, ends up being that gets handled by one particular service. You could partition by bounded context, which is sort of a domain-driven design way of well, here's a functional area of my domain model, and we'll implement a service that will implement that with a service. And then we could partition by verb, so we have a service that's responsible for a particular task, like checkout, for example. And then there's some other guidelines we could follow. So in object-oriented design, there's the single responsibility principle that says a class should only have one reason for change. In other words, one responsibility. And we could apply that model to services as well. Which are actually kind of conflicting definitions, because bounded context is effectively quite a big thing, and whereas a single responsibility kind of service would be a tiny thing. And then you could also base it off Unix utilities, right? Where instead of, we've got lots and lots of small things, cat, grep, find, which really just implement one particular thing. And then, there's a risk of having too few services, which means you just have sort of one big monolith, you have a few big monoliths, and you haven't really solved the problem. And in theory, you could have too many services. This sort of in SOA, they call that the nano-service anti-pattern, where you've sort of taken the complexity out of the service, out of sort of the actual code, and you've moved it into the connections between all of the services, and no one can understand how all these different services collaborate. And there's always the potential risk of excessive network hops, which could potentially impact the response time of your application. But it's somewhat of an art, and part of it is you just from my perspective, microservices is all about functional decomposition, and it's not about building tiny, tiny services. But just to contradict myself, here is a tiny service that handles incoming SMS messages from Twilio and replies with a text message saying, please register using this URL. And in theory, you could actually build something this small, and you just deploy it, and it's sitting out there, and you never ever have to touch it again, which is quite nice. But sort of more realistically, you kind of want to decompose your application to solve actual problems that you're having, as opposed to pursuing kind of the goal of tiny 100-line services, which some people advocate. And if you look in the real world, I think most of the sort of high-profile internet companies all have what you could loosely call a microservice architecture. Though when they did it, the term didn't exist, right? And interestingly, all of them actually initially had a monolithic application, which became too cumbersome. And then at that point, they sort of had a big refactoring effort and split their monoliths up into lots of services. And each one of these is worth reading about. Like Netflix, they talk about having 600 different types of services. And they've got some kind of cute dependency graph that no one can understand, but it all just works, right? And then Amazon, they talk about, in order to render a product page, hundreds of services get invoked. If you actually look at an Amazon product page, there's the basic product description, there's also the price, there's the reviews, there's the rankings, there's the fact that, wow, you ordered this product 3 months ago, right? There's all these little bits of data, And you can imagine each piece of the data comes from a different service. Though it's slightly hard to imagine how you get to 100 different services. But apparently that's how it works. So why do you do this? Well, there's a bunch of benefits, right? So number one, your app, instead of a big complex monolith that no one understands, you've got lots of small, simpler applications. They're easier to understand and develop, which is good. It avoids all this jar class path hell of like conflicting versions of jar files. And it also eliminates, for the most part, OSGI, which was really designed to solve the problems that you get inside a monolithic application. Like it gives you redeployable modules and so on. But now we get that for free inside a microservice architecture. Each of these apps is faster to build and deploy because they're tiny. They got reduced startup time, which is good. And then it also lets you scale development. Each service can be managed by a team that is developing, deploying, and scaling their application independently of all of the other teams. It also improves fault isolation. So a memory leak in one module inside a monolithic application will actually bring down that whole monolith, whereas in the microservices architecture, it just impacts that one service instance. And then, really important, it actually eliminates any long-term commitment you have to a particular technology stack. These services tend to be kind of small. You can periodically throw away the code, rewrite them using a new technology. It's almost like with every new service you add, you actually get to kind of start over, look around, pick the best, what you think should be the best technology to implement that one service. And if that happens to be Haskell, well, you can give it a go. And if it works for you, that's good. Otherwise, if it doesn't work out, well, you actually haven't invested too much effort into it. So it kind of lets you move into this world of these modular, polyglot, multi-framework applications. Now, of course, we should all be using Spring, right, Josh? But, the reality is there's lots of other options out there. Apparently, okay, take it back. I wrote some Node code. Yeah. But you can think of the system as having like two different levels of architecture, right? You've got sort of the system level, which is the kind of the fairly stable architecture, perhaps designed by people who use PowerPoint and not actually write code, where they define what the services are and how they communicate and so on. But then the other level of architecture is at the level of individual services, and at that level, the developers who are working on that service, in theory, can pick whatever technology they want, provided it implements the right REST API or communicates on the message bus in the right way. And they can just pick the best tool for the job. And there's like Fred George, if you go Google his talks, he kind of talks about programmer anarchy, where it's like you just let developers loose and they just make their own localized technology decisions, which of course makes people from big companies very, very uncomfortable. But you look out there, there's a ton of really interesting languages, whether that's Clojure or Scala, Node.js even. Very interesting frameworks, Play and Spray and Akka and Spring Boot that Josh is going to talk about, because that really is the best, right? And so we get to experiment, but the big point is you get to experiment with these new technologies, incorporate them into your applications so you're never actually stuck using old, obsolete technology. And then what's even better is if you try to use one of these frameworks and it fails, you haven't actually kind of invested that much time. It's not a disaster. So a lot of great benefits, but then there are a whole bunch of drawbacks as well. So number one, complexity. Right? The monolith is that approach is kind of simple, But now, in comparison, the microservices architecture has all these different levels of complexity. So, for example, you are now building a distributed system. So, whereas before, when module A called module B, that was just a language level method call, which is really, really simple. Now, if module A calls module B, that's a remote call. So you have to deal with RPC or messaging. You have to deal with partial failure, right? A is up and running, but B might be down. And how do you deal with that? And it's just tons and tons of complexity there. The other really interesting thing is, whereas before we had one database, nice ACID database, now each service will typically have its own database, yet at the same time, we're going to have kind of logically business transactions that need to update entities in multiple databases. And in the old school, we would use two-phase commit for that, right? But that's sort of completely out of fashion these days. And so we end up with, instead of an ACID model, we end up with an eventually consistent model, which adds complexity. Plus, there's the complexity of testing. Before, we could just spin up the app, test it with Selenium, test it with whatever. Now, if we want to test a service, in theory, we might actually have to spin up the transitive dependencies of that service, which is really kind of complicated. We've got all the complexity of deploying and operating a distributed system. You need a lot of automation for that. And then also, interestingly, whereas if you're developing individual services in isolation, microservices are great because everybody can kind of work independently. But then if you need to implement features that span multiple services, there's actually a whole bunch of complexity with planning that and rolling out the changes in the right way. A lot of careful coordination. And then finally, there's sort of the big issue of, well, when do you use it, right? Like, so if you're a little startup, you don't have any users, you don't have any scalability problems, and you probably don't want to use this approach because of the complexity, and it's going to slow you down. The trouble is later on when you're successful, you do have scalability problems, and yet you don't have a very modular architecture. So refactoring to a microservices architecture could actually be quite painful. So it's kind of a tricky thing as to when to use this approach. Anyway, I think this is pretty much all I had to say. So in summary, when it makes sense, functionally decompose your application. Use the scale cube to sort of guide you there. So you end up with an architecture that's comprised of services that can be developed and deployed, scaled independently of one another. So anyway, that's my part of the talk. And I guess got a couple of minutes for questions. If anyone has any. No? Oh, yeah.
I think, and I've seen your other YouTube video, and I've kind of been following this topic for a while. I think the thing I'd like to see more of, and this is maybe a gentle hint for the next group, or when you can put one together, but focusing more on the complexity, because I don't think many people will doubt the benefits and sort of the challenges. But I think what I'm facing, what I'm experiencing as I'm actually trying some of this out, is exactly that. And I don't think there's sort of any answers that I've seen where that's addressed in any way.
Well, awesome that you should say that, because that's what Josh is going to talk about.
And I've seen a lot of your YouTube videos.
I'm sorry. You deserve better. But
that's why I'm here, because I deserve better.
Exactly. No, the next hour and a half is all about that piece.
Awesome. I'm looking forward to it. So
we'll get to
I'll complain to you.
Yeah. Yeah, we'll just...
This is sort of per your very last slide there. Are there any rules of thumb, so let's say you're starting out, hoping to grow to the point where you might need to develop a more distributed set of services, how you would kind of get going with your initial, probably monolithic application, so it would be to...
Yeah. Well, I mean, I guess a good thing to do is try and kind of use a methodology for designing your, say, monolithic application that actually enforces a lot of modularity. So like, one of the things I talk about in my other talk, which is about event-driven microservices, is that it's like the building blocks of your app are these loosely coupled things or components that only communicate by exchanging events. So even though you might actually deploy them as a monolith, in reality they're actually very loosely coupled, and so later on you can kind of tease them apart and deploy them how you want.
So would this be kind of a use case for something like Spring integration or something?
I mean, that's another possible technology as well. Like, use that sort of message-oriented architecture to just tie together the individual pieces of your app, as opposed to having like a big tangled domain model. I mean, you're certainly still incurring by going the modular route, you're sort of incurring a certain kind of upfront cost in a way, but at least it's all within the JVM, same JVM, and it's somewhat the cost is somewhat minimized. I think, yeah.
What about orchestrating the calls of multiple services? If, for example, your UI needs to gather some results from services A, B, and C, but the problem is that the input parameters for service B depend on the output of service A. If you do the calls sequentially, you will run into huge network.
Oh, yeah. So I mean, that's a whole other topic, and I cover that in like the full talk where I talk about the API gateway, where that like can expose an API, and then internally it's actually composing multiple calls. I mean, if there's a sequential dependency between them, then you have to do things sequentially, right? But if they can be done concurrently, then there's a whole bunch of technologies like RX Java, which let you write composable concurrent code in a fairly straightforward way. And in fact, that was kind of the motivation for Netflix's RX Java, was to kind of solve this exact problem of back-end API composition.
RX Java. Okay.
Yeah.
How do you handle inter-process communication? Like, does everything just implement a REST API, and that's how the...
Well, yeah. So, I mean, there's really two choices, right? So one is really, well, crudely speaking, it's REST, right, which is good. There's pros and cons of that. The other approach is to have a message-driven approach, right, where, so like the architecture I've been working on, components exchange events, which was basically messages. And it's sort of, you could end up using a mixture of approaches. I mean, in many ways, loosely coupled asynchronous is best, but then sometimes you need a synchronous call, and REST is a good way to do that. And Josh might have something to say about that too. Awesome. Anything else, or is it time for the main act?
Could you just clarify what you mean by events? I mean, do you pass them through a queue manager like Rabbit or?
Yeah. You just kind of. I mean, the sort of different technologies that you could use. So the generic one would be something like RabbitMQ, just a message broker, for example. I mean, the stuff I've been doing is a bit more specialized than that. It's using event sourcing, and so there's an event store. But that's like a whole, but an event store is kind of a combination of a database of events plus a message broker. But abstractly, it's just asynchronous message-based architecture. Oh, well, yeah, I could throw out CQRS as well. I mean, but that's what I'm working on. But that's like a whole other talk.
Okay.
All right.
Nicely done.
Hey.